Hello and welcome to another video. In this video we're going to be working on isomorphic strings. And so in this problem, two strings are isomorphic if the characters in S can be replaced to get T. All occurrences of a character must be replaced with another character while preserving the order of the characters. No two characters may map to the same character, but a character may map to itself. So in egg and add it's true because we can map E to A and G to D, and that will work. In foo, it can't be because there's two O's here and there's an AR, so the O can't map to an A and an R. And in paper title is also true. So let's go through the paper title. So the way to make sure that no two characters map to the same character, you basically have to have a one-to-one relationship. So every character in here has to map to a unique character. So like if P maps to T, there can't be another character that maps to T. So for example, if this was like Taylor, then this wouldn't work because then P would map to T and L would map to T. And the easiest way to do that is to make a hash map with both sides. And then if there is already a value, you keep it, and if there's not, we'll add it in. So let's kind of walk through that solution, and we'll just go index by index. So first index, we have a hash map for both of these. So P, we check, does it map to anything? No, it doesn't. So it will map it to T. Then we'll map it here as well. So T will map to P. And then we check, like, are these equal, basically, right? So like, does P map to this character? Yes. And then does T map to this character? Yes. And then we go for the A. So A, there is no value, so we'll map it to I. And then I will map to A. And we check, okay, does this value equal this value? Yes, it does. And does this value equal this value? Yes, it does. And then for the P, so the P already exists, so we don't need to like do anything, right? We can just take these values. So we check, does T equal this value? Yes. So if it exists, we never update it because we want these to be unique, right? Like that way something like Paler would fail, and we can walk through Paler as well. And then for E, E maps to L. So E maps to L. And here, L maps to E. And then we check again, does this L equal this? Yes. Does this E equal this? Yes. And finally, R to E and E to R. So R does not exist, so R to E, E to R. And then they do indeed match, right? So we're done. So let's take a look at Paler and see why Paler would fail. And let's try to maybe write these a little bit bigger if possible. So let's see. We can zoom in too, I guess. Okay, so let's take a look at Paler. So this should fail. And let's take a look at why. So here we have P. We can even draw it to make it bigger. So P, it'll map to T, and T maps to P. And these are indeed, like this P is equal to this is equal, right? So then A is not in here yet, so it'll map to I. And then I will map to A. And then L, so this is the part where it should fail. So L will map to T. But T is already in here, so we don't need to remember if the value's already in here, we don't change it. We only input new things. And then when we check, does this P equal this L? It does not. And that's where it would fail. That's why Paler would fail. That's why foo would also fail. So let's just do that last example of foo and bar. So if we have foo and bar, make this bigger. So here, F will map to B. B will map to F, that part's pretty straightforward. Then O will map to A, so far so good. A will map to O. Now in this last one, so O will not be changed, so O will still be mapped to A, and then R will be mapped to O. And then this is why you want to have these two dictionaries, because then we check, does this A equal to R? No, it does not, so you fail. So that's why you just have two dictionaries. You put in values if they aren't in there, and you just check, does the value in one dictionary equal the letter in the other, and so on. So pretty easy. So let's do that. So we're going to have two dictionaries, and they're going to be a character to a character. So we'll say map character. This is going to be like, we'll just call this like SS or something, just to pick some easy name. And then this will be a new hash map. And we'll have the exact same map for T. We'll call it like TT. And you can obviously think of better names, but T count or whatever. Okay, now we just have to, so the other thing we can do is that I forgot is if the strings aren't the same length, then obviously there's no solution because nothing can map to like an empty character. So we can check for that first. So we can say if s.length does not equal t-length, this is just always false. Okay. So now we have these maps. Now we can just loop through the indices of one of these because they should be the same length. So we can say like for int I equals 0, I is less than s, let's say, I plus plus. Then we get both characters. So we can say like character s character equals s character at I. It's actually like this. And same thing for t character. So t character equals t character at I. Okay, so now what we have to do is we have to put this t character into the hash map of s unless that value already exists. So we can easily do that. So we can say ss.put ss, and then we can use a getter default here. So this just basically says if there's a default value, let's get that. Otherwise, we'll put in t. So we can say ss.get or default. Very useful in my opinion for hash maps. So this is going to be the key is going to be s character. So if there is something, we'll take that. Otherwise, we'll put in t character. And same exact thing for the other one. So tt. Definitely not good variable names, but okay. So this is just going to be reverse. Okay. So now we have to check, does this value in like once we have these values, I guess I deleted it. Once we have this value, like what is this s map to? Does this value that we get here equal the character in t, and does this value that we get here equal the character in s? So we can say if ss.get, now the value definitely exists, s character does not equal t character, right? The s character should map to t character, and the other map should also be true in order to preserve that one-to-one. So this is going to be tt.get t character does not equal s character. Then there is no one-to-one, so we just return false. Otherwise, we just keep, and I think this like spacing is screwed up here, but that's fine. Otherwise, we just keep doing this, and then we finally, at the end of the loop, we return true if we were able to get through the whole thing. So let's see. Yeah, definitely the spacing is screwed up, kind of weird, but whatever. Okay, I guess what we can do is we can do like this or something. Sure. Okay. So let's see what errors we get. Incompatible types, character cannot be converted into a character. Always screw up something stupid, so let's see. So getter default. Oh, this should be not ss, this should be s character and t character. Okay, let's see. All right. And there we go. So it does work. So essentially, and the nice thing about using these hash maps is just like in Python, because this is only probably like lowercase characters or something, any valid ASCII characters. But in either case, there's not that many ASCII characters. That means these maps won't be too big. There's like, I mean, I guess there are a lot. I'm not exactly sure like how many there are, but let's say out of the common ones, there's like 200 or 300. It's like nothing. So this hash map won't be very big. Yeah, so let's go through the time and space. So time is just going to be the length of one of these. So it's just going to be like minimum of length, like, or we'll call it minimum of s and t, because if they're not the same length, we always return, or I guess technically, no, it won't be minimum. It'll just be like length s or something, let's say. Because if they're different lengths, you'll always return, you'll just return false and O of 1. So they always have to be the same length, so just call it like O of s or something. And space, so yeah, you'd have to have a hash map of every single ASCII value. So like I said, depending on how many ASCII values, I don't know, we'll call this like O of ASCII or something. And yeah, I think that's going to be it for this one. So pretty straightforward. So just a reminder, the way to do this isomorphic thing, just make sure there's a one-to-one relationship. So every character in here maps to a unique character in here, and every character in here maps to a unique character in here. And that ensures that there's a one-to-one on both sides. So that's how you do it. And this is like relevant to a bunch of other problems that are obviously more complicated. So if you want that one-to-one, you just have a hash map for both, and you check that it's true for both. And yeah, it's going to be all for this one. So hopefully you liked it. If you did, please like the video and subscribe to the channel. And I'll see you next one. Thanks for watching.